we've been talking about has been classifying numbers. That's what we're going to use today. And today is your first lesson in the unit on complex numbers. So I'll pass out these first. You can see them. Kenny, and there's one for her.
Thank you, Kenny.
That's her one.
I'll help her over here.
Okay, I always put the goals up on the board. So the goals for today is students should know that the real numbers, rational numbers, irrational numbers, integers, whole numbers, and natural numbers are subsets of the complex numbers. We'll get to that later. Students should understand that the imaginary number is called I, and it has some properties we're going to learn about. Students should be able to write numbers in the complex form a plus bi. Students should be able to perform basic algebraic operations with complex numbers. We'll dive into that a little bit later. And then our standards that we're going to learn about today is that there's complex number I, where I squared equals -1. And the form for that is a plus bi. And then we're going to add and subtract complex numbers today, and then we're going to multiply complex numbers a little bit later in the week. So here's your warm-up. I want you to solve each problem on the top of your handout there, and then I want you to classify each of the answers: real, rational, natural, integer, whole number, irrational, or imaginary. There is multiple for each one, and we'll go over those in a little bit.
Okay.
Did you get a handout?
No.
Yes, right there.
Oh, yeah.
Oh, okay.
Yep.
I was making
Thank
sure
you.
you got one.
Yeah.
Five is impossible. It's #1.
We'll get to that, Kenny. Good observation. How's it coming, Jeremy?
Oh, it's going well. I'm
Going well?
on step 2.
It's alright. Take a while.
I'm slow.
It's okay.
Are you supposed to know the definitions?
What do you mean the definitions?
No, the underneath. Right here.
No, we'll get to that in a little bit. I just saved some paper.
Oh, wait, do you want us to use this then?
No, you're supposed to write it up here.
You know the definition of these?
You should from later or earlier on in the year. If you can't, that's okay.
Oh,
We'll talk
I
about
thought
it.
you would probably want to use
No,
it.
we will, but I just wanted you to write it down later too. Steven, need a little more time? Are you good?
I think it'll be alright. Yeah, good.
Okay. So what did we get as our first solution? Steven?
X is equal to 5.
Good job. And what did you have as your
there was a real number, a natural number,
Just gonna abbreviate, guys.
it's an I think integer too.
Yep, good
I
job.
think it's an integer, and then a whole.
Whole.
Um,
Anything else?
I don't know, that's all I had, but maybe,
Forgot rational. That's okay, we'll talk about that, Steven.
okay.
Sam, you'll do the second one?
So I got x is equal to -5.
Okay. And how did you classify that one?
I kind of guessed.
It's
Let's
alright.
go integer. Maybe. Nope.
Yep. Integer. Anything else?
Whole number.
It's actually not a whole number, we'll talk about that.
All right. Let's try rational.
Rational. Anything else?
That's what I have.
Forgot real, but that's okay. Oops. It's alright, we'll get to that. Jeremy, you wanna do the third one there?
I have x equals 1/2.
Good job. And how did you classify that one?
That would be, well, I classified it as rational and real.
Yep, very good job. Kenny, fourth one?
X equals the square root of 2 plus or minus.
That's alright, we'll just do positive today. And did you classify that?
It's a real but irrational number.
Yep, very good job. And what about the last one, guys?
So it can't be solved. It does not exist.
DNA.
The limit does not exist.
I think it's negative, or is it imaginary?
It is imaginary, because it's the only one that doesn't fit. But we will actually talk about that one today. So, before we dive into number 5, and it's imaginary, we're first going to go over some definitions, because a couple of you missed some of them.
Gotta get a step stool.
So, a real number, sorry guys, is any number.
Oh.
There we go. Any number on the number line and it can be positive or negative. Just gonna abbreviate there. Example wise, I just wrote down some. If you guys have a favorite number, you can write that there, but you guys are getting it on your note sheet there.
It's pi.
This pi is real. Yes. I
But is it
put
on the number line though? Oh, it's not the number line.
it's a real number though. We'll get to that. So I put -5 and 8/3. Rational number. It's number that can be written as quotients of integers. And then an example of that would be 7/5. You also have terminating decimals. Does anyone have an example of that? Decimal that terminates?
1/3?
Not yet. We'll get to that in just a quick second. I
The
have,
same which you wrote above,
what?
7/5, 7/5.
Yep, that works. That does work. And then, what Kenny, this is what you're talking about. Repeating decimals. And you said 1/3?
Yeah.
Yes. So equals 0.3 repeating. Integer. It is our natural numbers that we just talked about. It includes 0, and it's also our negative integers. And I have I wrote it like that, so you guys can see that it's just the whole numbers basically. Now we have whole number. It is our natural numbers, including.
Wait, so would 8/3 be an integer? Or we're including it, all the natural numbers, but
In our warm up, what did we say for 1/2? Is it an integer? You said it was real and rational, right?
yeah. But for the examples in the real numbers, natural numbers, never mind. Well, no, natural numbers are, never mind.
We'll get there.
I confuse those and real numbers.
I know. We'll get there. I promise. Including 0. So 0, 1, 2, like that. Now we're getting to our natural numbers. These are just our counting numbers. So 1, 2, 3, like that. That's what our natural numbers are. Our irrational numbers are numbers that can't be written as quotients of integers. So I just have an example of that being 1.174563. You can't write that as a fraction. We also have decimals that don't terminate. And that is pi, Kenny. That's where your pi comes in.
For pi.
And then we have our positive rational numbers that can't be perfect squares. And I'll talk about that in just a minute. So if you have a number like square root of 25, that's going to equal 5, right?
Mm-hmm.
But what about square root of 3?
Not gonna end.
That's why it's an irrational number. Okay? An imaginary number, we'll come back to this slide in just a second. When you guys are done writing. How far are you, Steven?
I'm just writing down the examples.
Alright. Let me know when you're good. Okay. So now we're into to what we're going to talk about today is complex numbers. So looking at your warm-up problem number 5, this is your equation, and you get x squared equals -1. And since you guys solved it like you would normally solve it, you do the square root, and you get x is equal to the square root of -1. Now it's called imaginary because there's no number times itself to get a negative number under the square root. So that's where I comes in, and I is equal to the square root of -1. So your imaginary number I can be written in the form of a plus bi, where a and b are real numbers, but a here is the real part, and this one is your imaginary part. Okay? Any questions? No, that's a little confusing, first time seeing it. No? Okay. So now we're going to go back and fill this chart back in, which is basically what I just said. So you have I is equal to the square root of -1, written a plus bi, where a is the real part, and b your imaginary part. Example, you could have square root of -1, something like 3i. We'll get to how you solve that in just a minute. Good to go on, guys? Okay, so we have this chart. It's actually on the back of your handout there. This basically explains everything that we've gone over so far. You have your real numbers here, and then everything under that is basically what you have learned previously. Today, we're stepping outside of that box, and we're saying that these numbers are complex numbers. Why is it just 3?
I was gonna say that.
Okay. What did we say our form for writing complex numbers is?
What do you think?
Yeah.
Right. So if you have 3, how would you write that into your complex number form?
3 plus 0, 5?
Yes.
But there's still no
Yeah, there's no-
imaginary complex.
There still is. This is your real part, and this is your imaginary part, but it doesn't exist because
So would that make it just a regular real number?
right. And that's why complex numbers on the outside, because basically you can write any of these numbers on this chart or whatever we've gone over as a complex number.
So all real numbers are complex numbers, but not all complex numbers are real numbers.
Exactly.
Okay.
Exactly. So I want you to take a couple minutes and write these in the complex number format of a plus bi. I already did this one.